Hey Jacob, you've got company.
Oh hi, I'm Jacob Anderson. Welcome to my shop. Right now we're in my hobby woodworking shop. I am an avid woodworker who loves Shopsmith equipment. Over the years I've owned everything that Shopsmith has ever made. I got started repairing the Shopsmith tools after inheriting my father's Shopsmith, a 1962 Brownie model, which needed a lot of work. And over the years I've bought many Shopsmith outfits, all of them needing repairs. I became so good at it, I started repairing the machines for other people. In the past 4 years I've repaired over 150 Mark V headstocks, over 65 of those just in the last 6 months. This is where I do all my headstock repairs unless I'm at a customer's shop working on theirs. This tiny little corner here is perfect for me, space-wise. I'm surrounded by all the tools I could possibly need. It's near the front of my house, so it's more convenient for shipping and receiving of headstocks as well. You need snap ring pliers, because there's 2 or 3 different size snap rings that you have to remove. So I have 3 different ones of those that I typically use. And I also carry along assorted small parts. People are always losing the clips for the case, screws to hold them together, the set screws, all sorts of assorted little parts that can disappear. So I have good inventories of that. And then for the final reassembly, we use brand new bearings. Those are drive sleeve bearings there. There's some quill bearings, motor bearings, some idler shafts, the quadrant is frequently needed, and the control sheaves. I stock all of those on hand. If I have to go to somebody's shop to work on it, of course I'm going to carry along everything that I could possibly need. But again, I'd much rather do the repairs here where I'm surrounded by the tools and parts that I could possibly need. And I think this is the most important piece of machinery I have, is the bearing press, to remove your bearings and then press the new ones back on. You just would not be able to do headstock work for yourself without this. This is a 12-ton bearing press, and it's been worth its weight in gold to me. You also need bearing separators. I have 3 different sizes that I use. One of them is very beat up. So now let's get started working on a headstock. First of all, there's 2 ways to go about it. You can leave the headstock on the workbench and attack it that direction, or the way I prefer is to remove it entirely to have better access to all components for cleaning purposes and to access all parts. Unless I go to a customer's shop, I always work on the headstocks removed from the bench. So to work with it in place, first you need to remove all your cables and any attachments. Put the bench up into your drill press mode securely so it's not going to crash on you. Then you'll take your main work table, put it in reverse position, and that gives you a nice little workspace to set your parts on. Make sure you use something to keep your bench from being scratched. And this is how I like to remove the belt pan. Take the screws out, and then you'll need to tie the belt pan up high so it's out of the way. You can use a wire or cord, but a real easy way is just to use these handy clamps, which you already have in your shop. That'll make it easy to put it up and easy to take down. then you're ready to take out the 5 motor pan screws. It's easiest if you take out that front one before you put it up in drill press mode. It's easy to forget doing that. The other 4 will come out pretty easily. Once you get to the last screw, you need to be careful that you don't drop the motor and the motor pan suddenly. Of course, it's always easiest if you have a helper. I'm very used to working completely by myself on any project, so it's one reason I'm very well equipped with clamps. So now we set the motor down on the table, and you can reposition the headstock for access. Now here's the second method to actually take the headstock entirely off of the bench. Put it up in drill press mode again. Find yourself a 2x4 or larger board. Take the tie bar off. There's only 2 Allen screws holding it. It may slip off easily, or you might have to use a mallet or a piece of wood to help bump it up and off. Of course, make sure you're unplugged before you do all this. You lay the board directly under where the table legs will rest. You can see the table legs are resting on the board, holding the weigh tubes up at an angle. You can make sure the carriage and the headstock are locked in place, of course, so they don't slide around. Now it's just simply unlocking the headstock and sliding it right off. You can also do this with a helper. And when it's time to put it back on, it's quite easy as well. Just set the bench up like it was before if you moved it. The headstock lock wedges may shift out of place, so you might have to reach in and turn those so that it slides onto your weigh tubes like that, especially if the headstock has been shipped. When I ship them back to people, I leave the headstock wedges positioned correctly, but with all the vibrations and travel, it most likely will need turning afterwards. Okay, we're ready to get to work on a headstock, so as always, be sure to wear some good safety glasses. There's various little parts that could fly at you, including springs and retaining clips and things, so be safe always. And protect your clothes as well, so put on my Shopsmith apron and let's go to work. Okay, the headstock we're going to work on today is one that's made in the 1950s. These were the earliest headstocks. We call them greenies because of the color scheme. They were made from 1953 until 1961 when they changed the color. And I'm using this because the older the machine, the more likely it is to have more parts to demonstrate the repair on. So the way I always get started is first I remove the front motor screw. If the machine's running, turn it up to high if you can. If not, we can still work with it. And then I also like to take off, or at least loosen, the switch, electrical switch nut, so that I can pull the motor out with the switch in place. Okay, now I've turned the machine on its front, removed the hubs if any of them are on the machine. And then there's at least 2 screws holding on this belt cover. One in the front, one in the back. On these greenies, they also had several others, 4 or 5 down here, 3 more up top. You don't need that many, so if you have a greenie, when you go to put it back together, just use 2. The more screws there are, the longer it takes you to take this off to oil it and clean it later. course, make sure the machine is unplugged before you do any of the work. And I like to use a stainless steel container to keep all these little screws and things in. Now I can take the cover off. On the greenies, they were very tight, so it might take some prying like this. And now we can put the cover out of the way. Okay, on the early greenies, this back cover did not come off. There's no hole back here. But on everything from about 1958 on, this is a removable cover with a inspection port so that you can reach in to oil it. And in this case, it's good to reach in, reach through, and pull out that electrical switch before we do the next step. In this case, since this doesn't come off, it makes it a little harder to take the motor off. This is what the newer style looks like. This is the large inspection port hole on the machine since about 1993. Much bigger, much easier to use. Now if you have turned the machine up to high speed before setting it to work on, the belt will be at the outside of this sheave here, so it's easy to remove it. To get it out of the way, just simply lift the spring, peel the belt off like that. Now it's disconnected. And now we're going to remove the 4 remaining motor pan screws. So the motor case will be free. So on a newer machine, you'd be able to remove your switch with the cord attached. On this machine, I'm going to have to reach up in and do a little bit more work. Okay, so to remove this switch on the early greenies, I have to remove the quill from the housing because the early switches were quite large and hit the quill when you try to take them in. So to remove the quill on all machines, you have to take out this set screw here. It might be buried under putty, or in the newest machines under lead. So to get that out, you'll have to scrape out the putty or pull out the lead. And to do that, of course, you'd use a good pick. Sometimes you can use a very small screwdriver to help hit it too. So now I need to use a quill handle. Loosen your locks. I can extend this and pull the quill right out and release the spring tension gradually so you don't hurt yourself or the spring. Okay, now I've flopped the headstock back on its side. I can reach in here real easily, and with the quill out of the way I can pull this switch out. You can see why it was hitting the quill so large, but now I have the switch still attached to the motor and to the power cord. Okay, now we're ready to remove the speed control assembly. So by having it up in the V position, very near high, you can access the small set screw that holds this handle onto the shaft. Just work it off. And you can see there was a very small set screw here, which is what we were getting. Now there's 3 screws that hold in the speed assembly itself. I like to tighten them just to feel if the holes are stripped or not, so that I know later. And then I'll go ahead and take those 3 screws out. This spring is frequently missing. The spring keeps this from rattling. All 3 of those have to be very tight to hold this speed mechanism in place correctly. Now I flop it on its back again. There's a small clip from the control sheave that has to be removed. And now we can pull out the speed control mechanism and the speed dial indicator. On the newer machines, there's a small spring located here. On these greenies, there was this spring plate here, and that is to keep the spring dial from rattling in either case. So the entire speed mechanism is now free. Okay, now I'm going to remove the retaining clip that holds the drive sleeve in, and I'm going to take off the bolt that holds the idler shaft and eccentric in place. This area here is frequently filled with sawdust, so you may have to scrape the sawdust away to get to the retaining clip. But you have to find the little end of it. And it simply spirals out of place like that. Okay, now on the eccentric, there were several variations. On the greenies, they used a little bracket here to keep everything from being pushed back. On the newer machines, I'll show you there's a screw with a washer up here that holds things from being pushed back. But in either case, just have to take the nut off, set those aside, to relieve the tension. Okay, there's the bolt. Here's the brackets that are used on a greenie. So this is what the newer style headstocks look like. A retaining washer with a screw here. They use an Allen bolt, 1/4 inch size typically. So you just have to loosen that bolt there and remove this screw here. Okay, this little slot here allows you to adjust the tension on both belts. This is in the 6 o'clock position. When it's tensioned, it may be up here about 9 o'clock. So after you've taken the tension off of this area, you can use a screwdriver and a mallet to tap it back down to the 6 o'clock position. This applies to any of the headstocks. And then there's a very small set screw right up in the middle that you have to loosen. And that set screw keeps the idler shaft in the eccentric correctly. So we need that set screw loose. You can see it's loose now. And this allows us to remove these areas. Okay. So this is what it looks like outside of the machine. We were reaching up to this set screw here, loosening it so that these two pieces can be separated. The set screw locks into that little V groove to keep them properly aligned. On the newer machines, the set screw in the eccentric is not there anymore. Now they have an extra little lock bolt and lock washer to keep the idler shaft from extending beyond the eccentric. And that's in addition to the lock washer and screw that's holding everything together. So you don't have to look for the little set screw up in here if your machine looks like this. So if you haven't taken it off already, you pull off the control sheave from the shaft. That's the control sheave there. And the drive belt may still be in that area too, so remove both of those pieces. So at this point we're going to be swinging the idler shaft out. It's going to have the belt, the upper belt, around it. In this case it's a Gilmer belt, one of the tractor treaded type of belts. Newer machines have the Poly V belt, but basically we need to bring the idler shaft forward, basically in a swinging motion like that. There we go. Okay, so now the upper belt is free. So I pull it up out of the way a little bit. Since the quill has already been removed, I'm going to use this rod to push this drive sleeve out. I'm inserting it through the quill hole. In this case, the back bearing came off it as I was doing that. So there's the back bearing. It would be right there. Okay, I'm going to show you how to remove the drive sleeve using the quill as a piston to push it out instead of having to hammer it out with a large rod like that. So we have removed the set screw holding the quill in place. We have to extend the quill just about all the way. It needs to de-engage from the drive sleeve. Right now I'm still engaged because both ends are turning. Once I feel it disengage, now I just turn it out of sync with it just slightly. That didn't work. It just takes a little feel. Okay, here we go. Starting to push it out. Pick the belt up to get it out of the way. And there we go. The drive sleeve is out. This is a Poly V type of drive sleeve. Now I can take the quill all the way out. And I can lift the belt out of place. And there we are, ready to inspect the quill, the drive sleeve bearings, and the belt. Okay, at this point the only thing left to take out is the quill advance mechanism with the spring housing. So we just have to take off both handles on each side. This is frequently assembled incorrectly. There should be two washers with rough side facing in. There's the depth control. Here's the other washer. Rough side should be facing in towards this. And some machines have a plain washer at the very inside. The other side has the big wing handle, has a small spring washer. There's a single set screw located right at the top. Again, it should be underneath putty. So dig the putty out, remove the set screw, loosen the set screw. And you can remove the whole assembly. Now on the inside, there are two pieces. There's a domed washer, and there's a sleeve. So those pieces may have remained inside in this area here. Okay, so now we have everything out of the headstock that I typically remove. So I use this time to inspect the headstock casting for any cracks or damage. I look also at the headstock locks to make sure they're not too worn. It's rare to really have to replace any of those. But just check it all over for breaks. Look for breaks in here where that quill advanced mechanism was. Could be a break here, but I've never seen that. Check for cracks around the holes that the way tubes slide through. The most frequently damaged area is right here. Since this can be squeezed, it could be cracked by over tightening, or it could be cracked if a person has pried on it to release it. I check for cracks in these openings here. Check for cracks around the headstock lock area. Any damage here can happen from shipping. Check this area, and most frequent damage also is in this area here. If it's not packed properly, it could be impacted and cause some damage here. Also, I've seen them when they were dropped out of vehicles or fell on their side in a shop. I've seen damage there. These early greenie castings are super heavy duty, much more metal left in place. The newer ones are the more fragile ones. They didn't even give openings here for inspection. So more metal, much more metal in place. Also check down here where the motor pan is attached. If it was ever dropped, there could be some damage in those areas as well. So this is a newer casting here. You can see how much more metal has been removed so that you can inspect the belts, both sides, and a lot less metal around the eccentric lock area. So a little easier for them to be damaged. Okay, so now we have all the components out, and I'm going to start the inspection process. Look at the belts. The drive belt should be a minimum of a 1/2 inch wide. This one here is just under that, 0.49 inch. So it's too narrow, that throws the speeds off. Also, you want to look for places where it is coming apart. If it's got mildew or mold, the edges are rolled up. So there's a lot of things that can go wrong with the belts. So this one needs to be replaced. In this case, we have a Gilmer belt drive on the greenies. After 1962, they used the Poly V belt, where the grooves are parallel to the sides of the belt. Gilmer, the grooves are perpendicular. So on these, you just basically need to look and see if the belt's in good condition, if it's delaminating or split. A little bit of wear here, but that should be good for years. And you don't want it to be too stretched. Same thing here. I don't really bother measuring the width. I just look at the condition of the ribs, the condition of the belt sides, make sure it's not stretched, or if it's fixed in a position from sitting so long, you might want to remove it for that reason. Okay, and this is the idler shaft with half of the sheave still in place. We basically check the bearing to see if it's operating smoothly, or if you feel it clinking, or if you feel it rough. This receives strain from both directions. The upper belt's pulling this way, the drive belt's pulling this way. So it's not too often that they need replaced. But just give it a good feel. Watch this sheave as you turn it, see if it's bent. I've only seen one or two that were bent. In the case of the Poly V, this part is different. The shaft is the same. So this is what a Poly V sheave looks like. The shaft is the same, just the sheave is different. Okay, so now let's look at the drive sleeve. We're mainly looking at the condition of the bearings. Also, if there's excessive wear where the belt came across here, usually it's not too bad. But you can give the bearings a spin. If they spin freely like a roller skate blade would, then you need to replace them. Or they can be so rough that you can barely turn them. So just inspecting them by hand, you can tell if they're shot or not. These are most likely the original bearings. They certainly need replacing. Even on machines 5 years old, usually need to replace the drive sleeve bearings. And this is the Gilmer style. This is a drive sleeve with the Poly V style. Same exact bearings, just a different center section. Also, the ends are different. The Gilmer quill has a different spline configuration than the Poly V style quill. This is called the drive ring assembly, and this here is just simply a dust guard. On the Gilmer, the splines are molded into the shaft. On this one, the spline grooves are molded into the drive ring. So these are the back ends of the quills. This is what the Gilmer quill looks like. Very large splines. And this is a Poly V quill. You can see the splines are much finer. So next we'll inspect the bearing in the quill. The bearings were single bearing quills. The quills were single bearings until the early 80s when they went to a 2-bearing quill. So to get to the bearing, we have to remove this hub and then remove a washer, or a retaining washer. This may also be a set screw that's covered by clay or putty. So you just have to loosen the set screw. Usually they pry off pretty easy with a screwdriver, or you might possibly need to use a larger pry bar. Now you can see the bearing, and you can see the retaining clip right inside. So now I'm using a split washer, pair of pliers, removing that retainer. One side is curved, one side is flat. The flat side goes against the bearing, the curved side is front. Now we can knock the shaft out. Here's the bearing. This one spins way too freely. If you notice some wobble in your shaft, it's probably because the bearing is worn. The back end of the shaft is supported inside the drive sleeve. So the second bearing, if yours has one, it doesn't really do all that much, because this end of the shaft really can't wobble anyway, unless these bearings are really bad. So the single bearing quill, I think, is just as good as a 2-bearing quill. I see no reason to upgrade to the 2-bearing quill. People ask me that question all the time. Here are 3 variations on the 2-bearing quill. The first type is epoxied together and very difficult to get apart. This type with the pin is relatively easy to separate. And the final type has a larger front bearing, and the quill housing is larger with the bearings set farther back in like that. Okay, and this is the control sheave. It has a clip on it. It should have a small split pin in there that this goes into, so that's missing on this one. So this evidently came off before and was replaced without doing that other part. But these frequently need repair because this is a small bearing. I test them by spinning it, and I can feel if there's roughness inside. This one does feel rough, plus it's missing that one part. But I've seen them disintegrate inwards, outwards. It's just such a small bearing, and this operates at pretty high speeds. It can overheat. So this is a fairly frequent replacement. There's no way to just replace the bearing itself, so you have to buy this whole assembly from Shopsmith. On the speed dial, I just basically check the condition of the teeth. Don't really ever find them with messed up teeth, but it is possible. And I just check the back for clogged with sawdust. So there's not too much wrong with these. If yours gets really dirty, you can polish them up nice or repaint them. Okay, this part can have a lot of problems. This is the speed control mechanism. This portion here is called the quadrant, and it seems like about half of the machines need the quadrant replaced. There's 2 main wearing places in here where the control sheave rubs. You can get indents like you see here. This is kind of burned in, so that could cause your speeds to change erratically or unevenly. So I'd replace it just for that. And then the little rack of teeth frequently get distorted from pressure, so you usually have to clean this with a screwdriver to really see it. But if the teeth are quite distorted, you need to replace the quadrant as well. The worm gear, don't really have to replace it because of that reason, but there's a small retaining clip here, sometimes disappears. You might have to replace that retaining clip. This gear here is stainless steel, so usually it doesn't get worn. Here it's come loose. Needs to ride against. You can put some grease underneath to help it not squeak. So basically this is the piece that needs the repairs the most. You can also watch for these wings. Sometimes they get flared and have to be pushed back. With the quadrant, this is a brand new quadrant. You can see it's smooth. The teeth are even. So this machine, we're going to change the quadrant on it. Okay, this is the speed control handle. The main thing that happens to that is these little teeth here get stripped out. This is all cast aluminum, so it's very soft. So when the speeds get very hard to change, frequently you're chewing up these teeth. Right now you can buy the whole thing from Shopsmith, or Don Horn in California remanufactures these with stainless steel teeth, and those are the ones I prefer to use so that they won't get chewed up quite as easily. And you might have a missing set screw too, that sometimes they got lost. This is the outside of the quill, and basically you just look for any wear here, but that's extremely rare. The early machines, these were made out of nice beautiful stainless steel. The newer ones are anodized steel, but it's typically no damage to the rack here. The damage is on the other portion, the gear that drives this. So this is where the damage is usually occurring. This is a softer metal, If this part gets worn, you have to replace this whole shaft. You can't just replace that part. This here is the spring housing. So this is a crucial thing too, so that your quill snaps back in drill press position. If the spring is broken, you can replace this housing easier than just trying to replace the spring itself. But the spring is held on with a small pin, and it has a hole in the spring. Sometimes that hole gets stripped out. But in the case of this machine, it's connected fine, working fine.